Hey everybody, this is Mr. Grady. Welcome to another edition of CMA Math Academy. Let's go ahead and get started to what we're going to learn today. So let's go through what we're learning, why we're learning it, and how we'll know if we're successful. So what are we learning today? Today we're going to talk about how to compare the rate of change of different types of functions. So it might be a graph, it might be a table, could be an equation. There's also some word problems, I believe. So there's a couple different ways we're going to look at it. And be able to compare the rate of change from different functions. So why are we learning this? So the reason we're learning this is so that we can distinguish similarities and differences that functions have. So not all functions are the exact same, and we need to be able to see those differences and be able to compare them like we are today. And then finally, how will we know if we've successfully learned this? So later on at the end, you're going to be given multiple functions. You're going to be able to determine which function displays a greater rate of change. But the big part is you're going to be able to explain why and explain your thinking. So you're going to have to do a little bit of explaining at the end. Okay. So let's get started with where we're going to be. So we're starting at Carnegie 5.1, which is comparing linear functions. And that's going to take us to page m2-242. So we're going to do 242 first, then 43, look at 44 a little bit, and then at the end, like I said, you're going to be explaining some things, showing your work and explaining it on an explanations page. So I'm going to meet you guys over at M2-242. All right, guys, so we're over on page 242. So let's go through our directions here. Up at the top, it says examine each set of functions and determine which has the greater rate of change, if either, and then explain your reasoning. So a couple things here. So we're going to underline where it says rate of change. Okay, remember, rate of change is another way of just saying the slope. So all we're examining, or all we're trying to find, is which function has the greater slope. Okay. It also says explain your reasoning. That's really important. We're going to have a sentence to explain our answer for every one of these questions. All right, so let's look at this. So in question 1, we have table A and table B. We have to find the slope or the rate of change for each table and then compare it. Now remember, when we're finding the rate of change for a table, we're really just finding the pattern or the difference on each side. So if we look at the x's, we're looking for the pattern or the difference from -2 to +2 and +2 to 6. On the y's, we have -8 to -5 and -5 to -2. So if I think of this as a pattern, I'm thinking, how do I go from -2 up to +2? Well, I know that to do that, I need to add 4. So I'm going to put +4. Remember, we want to have a plus or minus, so this has to say +4, not just 4. Got to have that symbol. Then we need to see, how do I go from 2 to 6? Well, same thing. That's also +4. Okay, let's move over to our y's. So our y's, how do I go from -8 up to -5? So I'm going back towards 0 to -5. So I know to do that, I'm adding 3 to go back towards 0. And let's look at the next one, -5 to -2. Again, I'm going up from -5, closer to 0 to get to -2, and that is also adding 3. So remember, when I write my slope as a fraction, it's always y over x. So that tells me that for our table A, the slope or the rate of change is 3 over 4. All right, so let's look at table B. Same thing. We're trying to find the difference. So we're trying to find the difference from -5 up to 1. Well, I know to go from -5 up to 1, I have to add 6. Same thing here. From 1 up to 7, I add 6 more. Let's look at our y's. This is kind of tricky because these negatives are pretty big. But again, just think if I'm at -46, I'm going back towards 0 to get to -38. So that's adding. And then I just find the difference. Well, the difference from 46 and 38 is 8. So it's +8. Same thing down below. -38 going back towards 0 to get to 30 is +8. So that allows me to have my fraction. Again, fractions are always for slope, y over x. So my y value is 8. My x value is 6. But I also know that I can reduce that. Both of those numbers are divisible by 2. So I'm going to divide both of them by 2, and my final slope would be 8 divided by 2 is 4, and 6 divided by 2 is 3. So I have my slope. Now my job here is to determine which one of these is greater. So is 3/4 greater or is 4/3 greater? Now to do this, it might help to actually draw this out. So I'm going to be over on the left margin over here in the gray. So I had 3/4 versus, because I'm comparing them, 4/3. So let's think of this in an actual picture here. So if I had a circle, I'm going to shade 3/4 of it. So that tells me I need to split it into 4 parts, because that's my denominator, and I'm going to shade 3 of them. 1, 2, 3. So there's my shading. Okay. If I look at 4/3, draw a circle. Again, I'm going to split this up by my denominator, which is 3. So I have 3 pieces. Well, I need 4 of them, so I'm going to shade all 3 of these in. That's a whole. But that's not enough. I need a whole nother circle that I split into thirds, and I need to shade 1 more piece here. Okay? So I can see now that if I compare my drawings, I have 1 circle that's 3 out of 4 shaded, but then for 4/3, 4 pieces are shaded, which is really 1 and 1/3. That's kind of easier to see that, in fact, 4/3 is greater. Okay, so like I said, we need to explain this. We're going to write this in a sentence. So we've said that table B is actually greater, so we're going to write this. Table B found it? That's the one. Let me have it. Okay, so work on the spiral maths, and then we'll see what we have tomorrow I can give you, okay? All right, see you, Jake. Can you shut that door on your way out? Thanks, man. Has a greater rate of change because, we want to explain this, because 4/3, remember that was our rate of change for the table, is greater than 3/4. So we're just comparing those, okay? And there's our final answer explanation that I want you to have. Okay, so let's look down at number 2. I'm just going to kind of explain it, and then you're going to go ahead and work a little bit on your own. So let's look at graph A. So graph A has given us this line. They've also given us 2 points already. Now remember, when you're trying to find the slope of a line or the rate of change of a line, you have to have 2 points, and thankfully they already gave those to us. So we have 2 points. You're really just creating a triangle with the 2 points that are already made. So I'm going to start at my y-intercept point. I'm just going to make it a little bit bolder so you can see it. And I'm going to draw a straight line down and then over to the right to make my triangle that connects my 2 points. So if we look, we have this triangle right here. What's up? Mm-mm. I was going to say, I think he has one. Oh, I like that idea. Cool. That would be nice. Remember, when you create your triangle, you're counting. So as I counted 1, 2, 3 places down. So that's -3. And I counted 1, 2, 3, 4, 5, 6 places to the right. So that's +6. And that's what I use to make my slope. Now remember again, slope is y over x. So for us, that's -3 over +6. Again, we always want to reduce. So in our case, we can divide the numerator and the denominator by 3, which gives us -1 over +2. So I have -1 over 2 as my slope for graph A. So you're going to do a little work here on your own. You're going to find the slope or the rate of change for graph B, and then over to the left, you're going to write a sentence telling me which one has the greater rate of change. I do want to point out, for our graph B, there's a couple weird things about it. First of all, there's this point right here on the y-axis we don't need. It's not even on our line, so we don't need that. The second thing I want to point out is that this point at the right is not on a perfect corner. So normally the 2 points they give us we want to use. We don't want to use that point. So you're going to have to cross this one out too, and you're going to have to find another point perfectly on a corner to make your triangle. Okay? All right, your turn to work. Get this done. Okay, so we have two equations next. We've done a table question, we've done a graph question, now we have an equation question, then we have, as you can see, we finish up with a word problem. So let's look at question 3a. And again, we're looking for the greater rate of change, which is the slope. Now, if we look at our problem here, our equation, this equation is not written in slope-intercept form. Remember, we want all of our equations to say y equals mx plus b. Well, just by looking at our equation here, we can see that y is not by itself on the left side. We have these other numbers that have to get moved around. Okay. Now, we've practiced this a little bit, and I want to see what you guys can do on your own. So I'm going to give you a few seconds here. I want you to rearrange that equation to be in slope-intercept form. Ready, go. All right, so I want you to do a quick partner talk here, and I want, if you're partner 1, you're going to go first and you're going to explain what you got for your new equation in slope-intercept form, and then partner 2, you're just going to say whether you agree or disagree. If you disagree, we're going to have that conversation and try and figure out what went wrong or where you guys are disagreeing at. Okay, so I'm going to give you about 30 seconds to partner talk, starting with starting with partner 1. Ready, go. All right, so let's see how we did. Now remember, we want this y value all by itself. So we want y to end up being the only thing that's over here on the left side. So that tells us that this positive 6 needs to go and 5x needs to go. Now remember from what we learned earlier that we want to save the coefficient. So that's 6, that's with the y, we want to save that for last. So that tells us that we need to move 5x to the other side. Since 5x is positive, we do that by subtraction. Again, remember that since 60 does not have an x, you can't just subtract these and get 55x. It doesn't work that way since they don't have like terms. So we write out what it's saying. So for us, it's saying 60 minus 5x. We still have 6y over here on the left side. So we bring that down. Then finally, we need to get rid of that 6 by dividing. So we're going to divide everything by 6. So we end up with y equals, now we know 60 divided by 6 is 10, and we also know that we can't divide 5 by 6, and we also can't reduce it, so we leave that alone, which leaves our very last step of switching our slope, which is this end part, with our y-intercept. So we're just switching those two things. So I'm going to write mine to the right because I'm kind of out of room here. So we'd end up with, and you should have had y equals negative 5 6x plus 10. So then again, we have to figure out what the rate of change is. Well, we know the rate of change of the slope is in the m spot, which is right next to the x. So for us, we know that it is negative 5, 6. Okay? If we look at equation B, our equation's already in slope-intercept form, so that means our slope is negative 1/4. So again, I'm going to let you partner talk for a second. We're trying to figure out which one's greater. So is negative 5, 6 greater, or is negative 1/4 greater? Okay, so I'm going to give you a second, and I want partner 2, you're going to go first and see what you can come up with and have to say about this. And then partner 1, you're going to add your take on it. Which one is greater? Ready, begin. All right, so you've had a chance to talk. So on 3, we're going to say which answer we think it is, which fraction's greater, and then we'll talk about it and see if you were correct. So remember, you're either saying negative 5/6 or negative 1/4, whichever one you thought was greater. On 3, ready? 1, 2, 3. All right, so if we had this correct, negative 1/4 is actually greater. Now remember, like we talked about up above, with negative numbers, even though 5/6 is a bigger number, it has less value than negative 1/4 does. So in this particular problem, equation B had the greater rate of change. So let's write that. So equation B has the greater rate of change. And again, we need to have some sort of explanation. So for us, it is because negative 1/4 is greater than negative 5/6. And there we have our answer. Okay? So we're almost done walking through these together. You are going to get some time to practice. Let's look at 4 now. So now we have a word problem. So again, when I stop, everybody following along, everybody reading the next word. Here we go. So it says, an ice cream shop is a milk delivery. The Spotted Cow charges $2.80 per, plus a $2 delivery. Dairy Farms charges $2.10 per, plus a $10 delivery. Okay, so again, we're trying to find the rate of change. So basically what they're asking, or what they're giving us, is 2 different companies. We're going to write an equation for both, and then use those equations to answer the question. So let's start with the 2 companies they give us. Our first company is Spotted Cow. So let's just order our information here. So we have Spotted Cow over here on the left. So we're just giving us a chance to work. And then we have Dairy Farms. So let's come over here and let's write Dairy Farms. So again, just organizing our information here. All right, so let's see what we know about the Spotted Cow. We know that they charge $2.80 per gallon, plus a $2 delivery fee. Okay, so really, if you think about it, they've set up our equation for us. They've said that the Spotted Cow, so that's like Y, equals $2.80 per gallon, so that's X, plus, it even says it right in the problem, plus a $2 delivery fee. So there's that equation. Okay, so I'm going to give you about 10 seconds. I want to see if you can write the equation for Dairy Farms. All right, partner 1, you are going to share your equation first, and then partner 2, you're either going to say I agree, or if you disagree, you're going to explain what you find wrong with their equation. So partner 1's going first. Share your equation. Okay, so if we did this correctly, we should have seen that it was $2.10 per gallon. So that's Y equals $2.10 per gallon of X, plus, and then they add on $10 delivery fee. So their delivery fee is $10. Now again, all we care about is the rate of change. So all that matters for us is $2.80 and $2.10. Now we've practiced this a couple times. I want you to write your sentence saying which has the greater rate of change. So I'm going to give you a second to write your sentence. Go ahead and start. All right, we're going to start with partner 2. You're going to read your sentence. After partner 2 reads their sentence, partner 1 is going to read theirs back. Ready, begin. All right, so on 3, we're going to say our answer. It's either going to be spotted cow, if you went that direction, or dairy farms, if you went with dairy farms. So on 3, we're saying which had the greater rate of change. On 3. 1, 2, 3. All right, and we should have said spotted cow. All right, so I'm going to meet you over on the next page. So go ahead and flip the page. I'll meet you over there. All right, so we're over on page 243 now, and we're going to read our directions up at the top. Again, when I stop, everybody is following along. Everybody's reading the next word. So it says in questions 1 through 3, you're going to analyze the two distinct linear. You're going to identify which has the greater rate of change and explain your. Okay, so now they're giving you one equation and one graph. So before they gave you two of the exact same setup, this is a little bit different. So for 1a, the function a, we know again that the slope is always next to x. So this one's kind of easy for us. We know the slope on this one, or the rate of change, is 8. I'm going to give you a second to find the slope or the rate of change on our graph. Now remember, when there's no points given on the graph, it's your job to put points on the graph. So you need to find two places where our line is perfectly on a corner, put our points on there, and then figure out our slope, draw our triangle in. So I'll give you a second to work. All right, now the cool thing about this graph, or the easy thing about it, is that if you look, every single one of these corners on here could have been an option. So as long as you put your point somewhere on one of these corners, you should have been good. So on 3, we're going to all say what we got for our slope. Now remember, if our graph from left to right starts at the top and goes down, that makes it a negative slope. So your slope has to have a negative number or a negative answer. So we're going to say our answer for our slope on 3. Ready? 1, 2, 3. Okay, so we should have said -1 or -1 over 1. So what we're comparing is positive 8 from function A to -1 over 1. So this one should be hopefully easy to see. I'm going to give you a second, and over here to the left, I want you to write your answer and your explanation for which has a greater rate of change. Ready? Begin. Okay, partner 2's, you're going to start us off, and you are going to read your answer to partner 1. Then partner 1, read your answer back. Ready? Begin. Okay, so on 3, we're either going to say function A or function B, whichever one you thought had the greater rate of change. Ready? 1, 2, 3. And you should have said function A, and you needed to have some sort of explanation saying that 8 is a greater slope or a greater rate of change than a negative number. Okay, let's look down below. So you're going to get some time to work now on your own. So here's what you're going to do. You're going to figure out answer 2. So you're going to find our slope or our rate of change from the table, find it from the graph, and compare the two. Then you're going to flip over to page 244 and do this next one. Now if you look again on number 3, function e is not in slope-intercept form. We want this y all by itself, so we're going to have to do some moving. We're going to have to get rid of that 6x. Okay, then you'll come over here, find your patterns, find your differences for x's and y's, and compare that one, and then we'll come back and check our work here in just a few minutes. Okay, so I'm going to give you 4 minutes. See if we can get this done in 4 minutes. We'll check back. If we need more time, we'll get more time. Okay, so time starting now. Ready, begin. All right, our work time is up. So I would like for partner 1, you're going to explain your answer for question 2. So you're going to walk your partner through what you got for function C and how you did it, and function D, and then share your explanation with them. And then if you're partner 2, you're going to do page 244, so you're going to explain what you ended up getting when you had to convert our equation to slope-intercept form. Then you're going to come over here and explain our table, and then you're going to read your explanation to your partner. Okay, so I'll give you a moment here. Go ahead and partner share. Go. All right, so let's look at question 2, and on the count of 3, we're going to share our answer. So you're either going to say function C or function D. Okay, here we go. 1, 2, 3. Okay, we should have said function C. Function C has a rate of change. Whoa, that's not what I wanted. All right, so you should have said function C. Function C has a rate of change of 3 over 1. While our graph on function D has a rate of change of negative 1 over 2. So that negative hopefully gave that one away for you. Okay, so you should have an explanation there. And let's look at our last question here, which was over here on 244. On 3, we're going to say our answer, either function E or function F. Ready? On 3. 1, 2, 3. All right, we should have said function F. Function F has a rate of change of positive, 6 over 1, while function E has a rate of change of negative 6 over 1. Okay, so a positive is obviously greater than a negative, so that kind of gives that one away. All right, so let's look at our next little ending part here. So what you're going to have is a page where it has a problem, and the important part is the explanation. So either myself or Mr. Schrag are going to pass that paper out now. You're going to show your work through, figure out which function is the greatest function, and then show your explanation over in the box to the side. Okay? Great job today, guys.